Good morning, students. Yes, motion in a plane, uniform circular motion. What is uniform circular motion? When object performs motion on a circular path with constant speed, it is called uniform circular motion. What is direction of acceleration in case of uniform circular motion? What is its magnitude? Just we know acceleration is towards center. That's why it is called centripetal acceleration. What is its equation? That is A is equal to V square upon R, where V is speed constant and R is radius. Now for uniform circular motion, we will derive some another equations. We are taking the same condition. See, here it is. It is circular path. It is center O. Okay, it is center O. Object is moving in anti-clockwise direction. Initially, object is here at point P. So yes, it is its position vector. Yes or no? Yes, you know it. Okay. At time t is equal to t, it is initial position. After some time, particle is now here at this point P dash. So yes, it is its position vector. It is R, and yes, here it is R dash. Okay, and see. This position, these two position vectors make some angle with this center. Yes, it is let angle delta theta. It is just let angle delta theta. Clear about this? So see, when object moves from point P to point P dash, yes, distance traveled by object is this PP dash. Yes or no? But it also makes some angle with center. It also makes some angle with center. Initially it is here, okay, then it is moving, and see, it makes some angle with center, that is delta theta. So yes, see, this uniform circular motion is a special case of rotational motion. So like in chapter 3 we have discussed, okay, for motion in plane, motion in straight line. Okay, or in this fourth chapter we have discussed about linear speed, okay, velocity, acceleration, etc. The same quantities we have to derive for rotational motion. Okay, see, whenever object moves on such circular path, we can say it is a part of, or it is a type of rotational motion. And in rotational motion, you have to derive some quantities. See here. As object is moving from point P to P dash, it makes angle delta theta with center. Yes or no? Yes, it makes angle delta theta with center. This arc makes angle delta theta with this center. So here, this delta theta is called, angular displacement. Angular displacement means change in angle. So here, as this particle is moving from point P to P dash, delta theta is called angular displacement. Now we have to study one more quantity, that is angular speed. Okay, what is equation of angular speed? Angular speed is equal to, it is angular displacement. Upon time. Angular speed is indicated by omega. Angular displacement delta theta, and time interval it is delta t. It means when particle is moving from point P to P dash, makes angle delta theta and time delta t, then its angular speed omega is equal to delta theta upon delta t. Okay, and this omega, its unit is theta, means angle. Its SI unit is radian and time it is second. Okay, so its unit is radian per second. Now what is meaning of this angular speed, students? Angular speed means if any object is performing rotational motion, then with which speed it is performing rotational motion. In 1 second, how many numbers of revolution object performs? Clear? So yes, this angular speed means speed with which it changes its angular position. Okay, so yes, you have to remember delta theta is called angular displacement. Angular speed is equal to angular displacement upon time. Angular speed is indicated by omega is equal to delta theta upon delta t. Its unit is radian per second. Clear about this? Okay. Now, linear speed. What is the equation of linear speed, students? Yes, you know linear speed. Linear speed means v. Linear speed is not new quantity. Linear speed means v. And we know that this equation linear speed is equal to it is distance upon time. It is distance upon time. In this case, object is moving from point P to P dash. From point P to P dash. Yes, object is moving from point P to P dash. Object is moving from point P to P dash. So yes, it is called distance. Then how to find linear speed? Linear speed v is equal to distance traveled. It is called arc Pp dash. It is called arc Pp dash. This is arc Pp dash. Clear about this? Okay. What is time? Yes, it is delta t. Yes, it is delta t. Clear about this? So linear speed is equal to distance upon time. See, what is difference between them? Linear speed is equal to linear distance upon time. Yes, it is distance. Angular speed means it is angular displacement upon. Okay. Now, arc Pp dash. Remember one lecture of basic mathematics. What is plane angle? Plane angle is equal to arc upon radius. Yes, I can write like this. Angle is equal to arc upon radius. Then what is arc? Arc is equal to, it is angle into radius. It is angle into radius. Now see in figure, this is arc Pp dash. This arc Pp dash makes angle delta theta with center. And yes, what is magnitude of this position vector means what is radius? It is arc. Yes, you know it. Again, it is arc. This arc makes angle delta theta and radius is arc. Okay. So if I make subject as arc, arc is equal to angle into radius. This arc Pp dash, this arc Pp dash makes angle delta theta. So arc Pp dash is equal to delta theta. And what is radius? Yes, it is arc. Yes, it is arc. So now put in this equation, we will get V is equal to, what is arc Pp dash? It is delta theta into r upon delta t. Now we know that delta theta upon delta t is omega. So therefore V is equal to, here it is omega r. So yes, it is one relation between linear speed and angular speed. V is called linear speed. V is called linear speed. Omega is called angular speed. Is called angular speed. And this r is called radius. And this r is called radius. So yes, you have to remember this equation. You have to remember this equation. Okay. So yes, it is totally new concept for you. What is delta theta means angular displacement. What is angular speed? See, what is angular displacement? We will we will clear your concept more. See here, if it is x-axis, it is y-axis, origin. Initially, object is here at point A. At point A, then its position vector makes angle 0. So what is initial position? So what is initial position? Initial position theta 1 is equal to 0 degree. Clear about it? Clear about it? Okay. Now if object is moving on circular path and comes to this point B, yes or no? Then final position theta. Then final position theta. See, now its position vector is in this direction. It is R1. here it is R2. So now its position vector makes angle 90 with x-axis. Then what is its final position? 90 degree. Clear about this? Initially at point A, this position vectors makes angle 0 with x-axis. So its initial position theta 1 is equal to 0. Now on circular path it moves to point B. Its position vector R2 makes angle 90 degree with x-axis. So final position theta 2 is equal to 90 degree. Yes, it is position, angular position. It is called angular position. It is called angular position. Okay, so what is displacement? Yes, you know what is definition of displacement. Displacement means change in position. So angular displacement means change in angular position. Okay, so here what is angular displacement? Here angular displacement. Here angular displacement. Delta theta is equal to theta 2 minus theta 1 is equal to 90 degree. Is equal to 90 degree. Yes, object is moving from this point to this point. Then yes, you know what is change in angle? 90 degree. What is change in angle? 90 degree. Similarly, here change in angle is delta theta. So yes, it is a new concept for you. Clear about this? Okay. Now, in the last lecture, we have derived one equation of centripetal acceleration. Centripetal acceleration. What is equation of centripetal acceleration? AC is equal to V square upon R. But now I can write V is equal to omega R. So I can write this equation as omega square R square upon R. R cut, then is equal to omega square. Okay, this equation AC is equal to V square upon R. It is in form of linear speed. It is in form of angular speed. It is in form of angular speed. Clear about this? Okay. Two more quantities you have to remember. First time period. Okay, denoted by capital T. What is time period? Number. It is time taken by object particle to complete one revolution. It is time taken by particle or object to complete one revolution. To complete one revolution. Clear about this? Okay, if it is one circle starting from this point, then yes, it is moving, and again it reaches to the same point. Means it is called one revolution. So yes, time taken by particle to complete one revolution is called periodic time period. Okay. Second is frequency. Second is frequency, denoted by small f. What is meaning of frequency? Frequency means numbers of revolutions in 1 second. If I measure time, okay, 1, 2, 3, 4, 5, 6, 7. If it performs 7 revolutions, 7 rotations in 1 second, then its frequency is 7. So what is frequency? Frequency is number of revolutions in 1 second. In 1 second. So yes, you have to remember these two quantities. You have to remember these two quantities. Clear about this? Clear about this? Okay. If I am taking one rotation, see, for one revolution, starting from this point, 90 degree, does not know, pi by 2, 180, pi, 3 pi by 2, and when it completes one revolution, its angular displacement is 2 pi radian. Yes or no? Remember that unit circle. Okay, again, if it is starting from this point, pi by 2, pi, 3 pi by 2, 2 pi. So during one rotation, what is angular displacement? 2 pi. During one rotation, what is time taken to complete circle? It is t. So how to find angular speed omega? With the help of this equation, angular speed is equal to angular displacement upon time. During one rotation, angular displacement is 2 pi radian and time is capital T. Why capital T? For one rotation. What is time taken by particle? It is t. It is clear about this. Clear about this. And yes, yes, there is one relation between T and F. There is one relation between T and F. What is relation? See, what is T? It is time taken by particle to complete one revolution. Okay, so in time T, it completes one revolution. In time T, it completes one revolution. Then in 1 second numbers of revolution, in 1 second numbers of revolution, it is called frequency. Then yes, frequency is equal to what? If you simplify this relation, you will get F is equal to 1 upon T. So yes, there is relation between frequency and time period. Okay, so you can write this equation as omega is equal to 2 pi F. 2 pi F. Okay. Clear about this? So yes, you have to remember this each and every special case. First, what is relation between linear speed and angular speed? This equation, and what is time period and what is frequency. Clear? Now we will see some question based on it. See, example 4.10. An insect trapped in a circular groove of radius 12 cm moves along it steadily and completes 7 revolutions in 100 seconds. Question A, what is the angular speed? What is linear speed? Question B, is the acceleration vector a constant vector? What is its magnitude? See, understand it. An insect trapped in a circular groove of radius. So yes, you are given radius. Radius, capital R, is equal to, here it is 12 centimeter. Okay. Moves along it steadily and completes 7 revolutions in 100 seconds. Okay, revolutions 7, and time is 100 seconds. Time is 100 seconds. Okay, first of all, from this data we will find time period, capital T. What is time period? What is its definition? Remember, time taken by object particle to take or to perform one revolution. So see how to make relation. For 7 revolutions, time is 100 seconds. So for 1 revolution, what is time? Yes or no? You can make relation like this. Okay. For 7 revolutions, time is 100 seconds. So for 1 revolution, what is time? And for 1 revolution, whatever time takes, it is called time period. So therefore, time period. Capital T is equal to 1 upon 7 into 100. Clear about this? Yes, you can simply make one relation. For 7 revolutions, 100 seconds. So for 1 revolution, and for 1 revolution it is called time period. Okay, so if you divide 100 by 7, you will get approximate answer 14.29 seconds. It is 14.29 seconds. Clear about this? So yes, it is called time period, means to complete 1 revolution it takes 14.29 seconds. To complete 1 revolution it takes 14.29 seconds. Clear about this? Okay. Now you have to find, first question is what is angular speed? So how to find angular speed? Angular speed, its equation is omega is equal to 2 pi upon T. Yes, for circular motion you can use this equation for 1 rotation, for 1 revolution. Okay, omega is equal to 2 pi upon T. What is value of 2? Yes, so it is 2 pi 3.14. What is value of T? It is 14.29. 14.29. Okay, so yes, 2 into 3.14 divided by 14.29, you will get your answer 0.44. What is unit of angular speed? It is radian per second. Okay, so yes, it is angular speed. Now how to find linear speed? See, how to find linear speed. Linear speed, V is equal to, we have equation, it is omega into R. What is omega? It is 0.44. What is R? It is 12. So yes, you will get your answer, it is 5.3. But remember, Omega is in radian per second and this radius is 12 centimeter. 12 centimeter. So yes, here your unit is centimeter per second. Here unit of linear speed is 5.3 centimeter per second. Clear about this? Last question, question number B. See, is the acceleration vector a constant vector? No, we have discussed in last lecture. Acceleration vector is not constant vector. Is not constant vector. Okay, what is reason? See again, circle. If it is moving in anti-clockwise direction, at this point acceleration towards the center. At this point acceleration towards the center. At this point acceleration towards the center. Acceleration towards the center. Yes or no? See, this each and every value acceleration vector, they are different. They are different. But yes, its magnitude remains constant. Okay, acceleration vector is not constant vector, but its magnitude is constant. Its magnitude is constant. How to find its magnitude? Yes, AC is equal to omega square r. We have two equations. Yes, what is value of omega? It is 0.44 whole square and it is 12. R is equal to it is 12. Clear about this? Okay, if you calculate this, you will get your answer 2.3 centimeter per second. Okay, so yes, it is one question based on circular motion. You have to remember this thing first. For 7 revolutions, time is 100 seconds. Then for 1 revolution, what is time? And for 1 revolution, it is called time period. Clear about this? Next question is exercise 4.29. See, a bullet fired at an angle 30 degree with horizontal hits the ground 3 km away. By adjusting the angle of projection, can one hope to hit a target 5 km away? First of all, understand question. See, suppose it is ground. From this point, a bullet is fired at an angle 30. So let its initial velocity v0 makes this angle 30. Okay. With horizontal hits the ground 3 km away. Means this distance is 3 km away. Okay. By adjusting angle of projection, velocity you have to keep saying, but by adjusting angle of projection, can one hope to hit a target 5 km away? If target is here at 5 km away, then is it possible to hit this target? Is it possible to hit this target? It is your question. Now see, you are given only two data. If, how to solve this question? If you are asked, okay, can one hope hit a target 5 km away or no? You have to find maximum range. You have to find maximum range. Because what is meaning of maximum range? If maximum range is 10 km, then what is meaning of it? If you throw at any angle, okay, its maximum range will be up to 10 km, not more than 10 km. Okay, yes. When we will get maximum range? When angle is 45 degree. So yes, maximum range, its meaning is up to this distance object can move, object can be thrown. Okay, more distance, large distance is not possible. Okay, so here we will find what is maximum range. How? It is range, it is angle. Initial velocity is v0. Write equation of range because it is range. It is nothing but range. Okay, so range, its equation is r is equal to, it is v0 square sine 2 theta 0 upon g. Yes or no? Yes. Make v0 square upon g as subject. v0 square upon g as subject. Then yes, you will get r upon sine 2 theta 0. Clear? Now you may ask me one question, say why to make v0 square upon g as subject? We'll see. R in this case, what is range? V0 square upon G is equal to, what is our range? It is 3 kilometer. Yes, it is 3 kilometer. Okay, sine 2 theta here, R upon sine 2, theta 0 means 30 degree. Okay, and 2 into 30 it is 60. And what is value of sine 60? Yes, it is root 3 by 2. So yes, you can write this as 3 into 2 divided by root 3. And yes, if you simplify this, 6 divided by 1.73, you will get 3.46. Clear? Use equation of R for this data. You will get V0 square upon G as 3.46. Now, if you remember theory, what is V0 square upon G? V0 square upon G, it is nothing but, V0 square upon G is nothing but maximum range. It is maximum range, R maximum, and is equal to, it is 3.46 kilometer. Hello, do you understand? V0 square upon G is nothing but R maximum. So here R maximum, it is 3.46 kilometer. R maximum we can achieve when angle of projection is 45 degree. When angle of projection is 45 degree. So V0 square upon G is equal to 3.46, means maximum range is 3.46 kilometer. So if you adjust any angle, bullet will not move up to 3.46 from above 3.46 kilometer. Clear about this? It is its maximum range. We cannot fire bullet at a distance greater than 3.46 kilometer. So yes, as it is maximum range, yes, it is 3 kilometer. So yes, it is point of maximum range. So can we hit this target? No. Here 5 kilometer is greater than R maximum. So we cannot hit target. Clear about this? So yes, whenever you are asked some question, okay, when one can hit this target, one can throw this up to this distance, you have to find maximum range. Clear about this? Right.